Okay, so moving on, I would like to show you the last example. I only have a few minutes before the allocation is gone, so I have to make the most of it. And this is a different example. This is a Fortran example, and this is a code that crashes, but you don't really know why it crashes. So what I would like to do is to submit this job again through Allinea DDT, and I will use the memory debugging to find the bug, and more specifically, I will use the GAR pages to find the bug. So when the job starts, we have to go through this again. Let's see my job pending. Maybe I can. Yeah, all right. So that wasn't going to work. This line was commented. Console. Right. So now we are using the allocation. It should go faster. There you go. Coming up. Okay. So in this particular example, I would like to show you the GAR pages. So for this code, what is happening is, there we go, is that there is a buffer overflow somewhere in my application, and I want to detect where it is happening. So if I disable GAR pages, the application will run, but our may crash, but we will not see where it is happening. So I'm going to do a first run without the GAR pages to show you what happens. And after this is done, I will show you what the GAR pages, what's the difference and what happens when you do that. So the code is starting. There we go. Processes are being attached. I've got my graphical interface. If you have other questions, don't hesitate to ask. There we go. So we have our code happily loaded. And as soon as I get control, I'm going to play my application once. So if you use DDT on the CSCS system and that you're closer to CSCS, all of this should be much quicker. But in any case, keep in mind that this remote client is still much faster than SSH and X forwarding or VNC. So if I was to use X forwarding, it would be not possible to do the WebEx within the time frame. So the code is running, and I would expect it at some point to crash with an error. Okay, so it didn't even crash, see? So I've run my code and it runs successfully. That doesn't mean that there is no problem in this code. So what I'm going to do now, I'm going to restart this session. I'm going to tweak the memory debugging options in Allinea DDT, and I'm going to activate the GAR pages. So remember at the beginning of the presentation, I was saying that there were different types of bugs. Some of them looked random, chaotic, very complex. Some of them are unreliable. And this is typically a good example because this code does have a bug. It does generate the right results, but it doesn't mean that your code is correct. And the memory debugging option of Allinea DDT helps you find these problems. So what we recommend, so now we're using the tool interactively, but we always recommend to use Allinea DDT proactively, not just when there is a failure, but every time you make a change, run Allinea DDT in offline mode. You don't need to use the graphical interface for this. Activate the memory debugging and test your code. Just test that the code finishes correctly with the memory debugging without producing any error. And this is a guarantee that your application is correctly written and does not include any bug. So here my code is coming up again. I'm going to change at runtime the memory debugging options. So this is what I showed you earlier. If I go to Control and memory debugging options, I can change this and I can activate the guard pages. Okay. There we go. Memory debugging options. Right. All right. So I'm going to activate my guard pages here. I'm putting my guard pages after the allocation. So it's just one little menu to tick, and I play my code. And now you can see that Allinea DDT has stopped the execution. So again, memory error detected. So this means that the memory debugging features have found something. And this time, DDT is telling me that I have done a read-write beyond the end of an allocation. And it has stopped the execution on this particular line of code. So what's going on? We can have a look at everything we have. So on this line, there's not much stuff. There are two things. First one is the res array. The second thing is a variable k. If we look at the res array, if you select it, you can see here that you get at the bottom of the current line tab, you get information about what it is. So it's an array of real numbers, and it has 4,095 blocks. So this is the size of the array. So, okay, that's good, all well and good. The problem is, if you look at the k variable, its value is 4,095. So if you do an access on this array on 4,095 plus 1, you're out of bound because you're looking at the 4,096 block, which is outside the allocation. And this is exactly what Allinea DDT is telling you. You have a buffer overflow on this particular line of code. So in this case, what you would need to do to fix the problem, you make sure that you reduce this number, but you will have another problem here, which is if you remove this +1, you would probably end up with memory underflow, because now you're accessing the block 0 of this array, and initially it was starting at 1. So you would need to change this value as well to make sure that you remain inside the bounds of your allocation. And if you change this, re-execute the code, normally it will be fine, and you will not have any bug anymore in your program. So this is another example of what you can do with Allinea DDT. I mentioned